Great job. So we're going to move to our first panel, which is construction technology or smart building. And I'd like to introduce Dana Rowan, the former chairman, national chairman of NAOP. And Dana also managed a $3 billion portfolio where he was involved with acquisition and sales for Prudential. And he is currently the owner of the Exeter companies here in Boston. And we're also fortunate enough to call him our corporate development advisor. So I'd like to introduce Dana to come up and moderate the first construction panel. And if the people will come up, Chris and Mike. And Dana will introduce them, and you'll each have 2 minutes to introduce yourself and your company. Hopefully the mic works.
Why doesn't everyone come up and address the panel? That's great. Okay. As Noah said, my name's Dana Rowan. I've been in the business now for 40 years. I've seen a lot of technology come and go. And it's an exciting period right now. As Noah has indicated, our first panel is going to focus on building smart building, and we are we're just basically building technology. But I'll start with Chris. Why don't you just start by introducing yourself, and we'll go through the panel. Oh, sorry. We'll go through the panel. Yes, static KLEIN, right? Because we're all feeling that now with the approach of fall.
2 minutes or just introduction of
Yeah, why don't you just start by introducing yourself, your company, just a little bit about yourself, and then we'll go back and we'll go through presentations.
Sure.
How's that?
Hi everyone, and thank you for having me. My name is Christian BLOMDAHL, and I head up the lean practices for Suffolk Construction. We are a national CM firm, so a construction management firm. Number 23 or so in the US, about $3.5–4 billion big. Big jobs here in Boston. If you're from around here, the Millennium Tower we built. We're currently building the Encore Casino, and we're building the One Dalton job, the big one by the other big high-rise going up right now in the city. So we're affecting the skyline, and I'll talk more later.
Yeah,
Thanks for
we'll
having
just if you give a brief introduction of yourself and your company and where you're based.
Hi, my name is NIRVA FERESHETIAN. I'm the Chief Information Officer for CBT. It's a Boston-based design firm. We turned 50 last year, so this is our 51st year, and we do a range of projects from urban district planning to multi-family residential, large-scale, mixed-use, academic projects, civic projects, workplace, as well as repositioning. If you're familiar in Boston, we have lots of work on Seaport Boulevard, 121 Seaport with Skanska is our project. We were on the Amazon headquarters bid designers for with HYM, and we have multiple residential buildings all over town.
My name is MEAGAN. I work for Centria, which is an international building enclosure materials company. We're based out of Pittsburgh, and I just recently moved to this area out of Salt Lake City, Utah, so if I reference a project, it might just be in Utah.
My name is Jared Curtis. I'm the founder and CEO of a company called World Homes, or WOHO, here in Boston, and based in Madrid, Spain as well. We're a turnkey building provider for the multifamily industry, a new take on modular construction that uses AI and automation in the design process to enable robotic welding and material handling to dramatically reduce the amount of on-site labor that's required, which brings down the cost of construction and allows for housing affordable to middle-income families in cities like Boston, New York, and in California. That's where we're starting.
Great, so my name is John Klein. I'm an architect, principal of JKD here in Boston. I'm a Bostonian. Also a research scientist over at MIT, and we're doing a lot of work investigating mass timber technologies and industrialized wood construction. So looking at buildings as kits of parts, looking at different kinds of processes for off-site manufacturing and more sophisticated on-site assembly, ultimately leading to more sustainable carbon neutral buildings.
Great. So we actually we'll go back to Chris, and if you could now just provide each of us with a kind of a 5-minute overview on your company's activities in the market in the context of smart building.
Yeah. So for us, as the construction manager, I think the focus that we have and what we've been working on is really about collaboration. And collaboration, of course, is the most sort of overused and trivial word out there. No one says that they don't collaborate. But for us, if we want to provide smart buildings, we do have to get much better at collaboration end to end, so we can actually provide that. And we've been looking a lot at what processes do we need to put in place so we can bring subcontractors in early, right? And that we can work closer with the design team, and if we want to use timber construction, that we can actually do that, and it doesn't get lost in the shuffle or during the VE process, but that we can actually provide the smart buildings that the clients are asking for. And we certainly use a lot of technology to get there, but for us it's much more about the process, about to enforce and to enhance that collaboration so it actually happens. And those jobs where that, you know, most case studies come from are always when all the stars align and we had a great team, but they're outliers and they shouldn't be. We should use them on every job. And so what we have done is we created a process that we're pushing in our organization and with the clients and architects that we work with. We can't boil the ocean, and what I find interesting is, as sort of a panel and a group like this to discuss, is what do we put in place to actually change that? Is it different contract language that we need to use? Is it more performance-based driven, you know, contracts or encouragement to actually make it happen? So we do provide these buildings that the clients are asking for. Great.
So I have a question. Are you actually taking steps now to modify your contracts to enable more collaborative work, like integrated project delivery? I know you've had some experience with that, that's going in that direction.
Yeah.
But our conventional contracts are highly adversarial.
Exactly. We are trying to, and in some cases, yes, the time contract changes. It is more that we are changing design requirements where we're actually asking for, and at this point it's more convincing owner and architect that this is a better way to do it. And so we haven't changed the contract, but if we could, that's certainly where we want to go, so to get out of the adversarial space.
And you do both private and public work. Public procurement has some pretty steep barriers
Yeah.
to
The focus is on private, right, yeah.
Okay. For the past 4 or 5 years, I think just like any business, we are digitally transforming the smart building part in terms of the virtual representation of the building is really born in our offices first. So we've been in heavily looking into immersive visualization. We are looking at different ways of doing analytics on our virtual representation of the building. We are using augmented reality and virtual reality as means of not only designing, but moving downstream into the building life cycle. And here are some of our analytics in terms of wind studies in our virtual environment. performance of the building in our virtual environment, daylighting analysis, as well as computational design computation, trying to calculate whether it's performance or outcome or optimizing the efficiency of the building. We are also looking on the spatial analytics of existing buildings in terms of collecting data from sensors, Wi-Fi information, and then pulling that information to be able to do post-occupancy studies and learn from that as we feel the entire building life cycle is something we can learn from as we provide the preliminary data to build the building, and then later learn from the usage and operation of the building and feed that back, either improving our design or improving new designs of the building. So I think we are very much a visual company, so if I say less, then I'm just going to let a movie run to kind of represent what we are trying to do. Really a convergence of the virtual and physical, and we're very much looking into this digital twin concept where there is a virtual representation of the physical building, and with sensors and other type of computational technology that is available currently to be able to completely operate and learn from the environment and provide really a real interaction to the users of the building, and in terms of their experience. So we feel that it will completely transform the way we work or live in these spaces, and as a design firm, we feel that we will significantly change in the way we create and design and populate these spaces. So I'm just going to let a video run to explain some of our virtual representation prior to any of the buildings being built. Participates in hackathons, participates in really computational processes, and use augmented reality and virtual reality in many different contexts. We work with software companies now. We work with testing products, software products. This is our hobby installations. So
what's the entire design of the dome?
For those of you that are familiar with the Housing event, which actually is happening in the second week of October, we are the designers for that space. Virtual using our virtual coordination process in VR. We normally don't do coordination anymore because we have industry.
So my name's Megan. I'm the district sales manager for New England. It's really big out here, so that's been fun. So Centria has been around for ages, and we're an insulated metal panel company. So what I'm going to talk to you guys about today a little bit is that smart construction of how to save costs for construction. Right now, labor is one of our biggest challenges, and so we have an insulated backup panel that kind of mitigates the cost of construction. So, smart buildings, innovation, it's a noun, new method, idea, product, or etc. So what we have is our metal wrap series. Metal wrap replaces the traditional multi-component rain screen to where you're only having one point of contact. Much like our speaker was saying, it's easier to have one point of contact and one installer versus many installers, especially when you're going through commissioning agents and you have to then see if there's any points of failure in your envelope. So we recently completed a study back in April and released it. We worked with a third party to research and develop on a project in Florida where we had half of the building, two exact buildings that connected in the middle. We had half of the building with a multi-component and the other half with our single component. Through that, we were able to see that metal wrap was able to have 981 square feet a day versus your multi-components. Yes, they had a lot, but because you were putting on 4 or 5 different components of your rain screen, you had labor going around versus having a complete full package. Once those areas were complete, you were able to enclose your building and start on your inside trades as well as your landscaping trades. So as you see here, we were able to take the assembly 63 days to complete for metal wrap. We saved about 37 days for our best time and 24 days on our average time. What those days cost for construction and labor is pretty phenomenal. And what we did is we grabbed the fixed costs and our variable costs on that. We kind of threw up some numbers and saw exactly what you were saving. So with those 27 days, you could save about $60,000 in your construction costs. So although you might be paying a couple of dollars more per square foot, what you're saving on the back end with labor, with GC time, with variable costs is really tenfold. So what else do we have from Centria that's been recently coming out? We have our new Intercept panels. I see a future where architects are using a lot more depth and texture in the building to break up the facade so you don't just have one giant thing going up the building. With that, we have our Intercept module panels. What's nice about these is that they do not need a fire rating because they're a non-combustible panel. We have a couple of different types. We have our levels where they go in or out of planes. Then we have our razors, which you're able to bring single plane up and single plane down. That allows the architects to work with texture throughout the building. So, and then also we have our perforated panel because who doesn't want to perforate a panel? We love to do that. It's great. And that's Centria, so I'm just trying to keep it short and sweet.
Thanks, Megan.
I'll keep it even shorter because I really want to see this new product that Noah's been hyping up to me. Also because I don't have a long presentation. We started WOHO effectively to serve the middle income housing market and the upper end of low income housing industry. Right now in Boston, we're all aware that the upper spectrum of households have innumerable options as to where they can live in the city. There are pretty great initiatives out there to support low-income residents. And the real estate industry serves both of those needs really well. We either build luxury housing, or we build luxury housing and subsidize it at the cost of $300,000 or $400,000 per unit of state, local, federal subsidies to make it affordable to someone who can only pay $600 or $700 a month in rent. But what about everybody else? Basically anybody, I'm sure none of us in this room earn between $50,000 and $150,000 a year. But if we did, it would be really difficult to find a place to live in the city. we think the only way to do that is by bringing down construction costs dramatically, by integrating design, engineering, development, and construction into a more integrated, prefabricated product. Cutting out a lot of middlemen, reducing the amount of on-site labor, still producing great housing units at mid and high-rise scales, but trying to meet a section of the market that right now is basically being forced to drive until they can afford it, living in beautiful places like Worcester or Quincy, but suffering not so beautiful commutes on the Mass Pike or 93. Starting to stifle growth in the city, and we're excited to tackle the problem.
John?
Okay, great. So, I'll also try to keep it short. So, I launched Mass Timber Design about a year and a half ago at MIT, and we've been gaining a lot of traction over the last year, quite a bit. And I usually like to start kind of with what motivates us, looking at the 21st century problems, and that comes back to looking at the increasing population growth and the transferring from rural to urban areas and cities. And over the next century, there's going to be a phenomenal increase in our city centers. And if we have to build an incredible amount of inventory to accommodate this hyper growth, the existing ways of doing it with concrete and steel production need to be understood in terms of the carbon impacts. And so this is an interesting chart that we look at, and on the left-hand side, so this is from the City of Boston 2030 Vision Plan, and on the left-hand side, you see it's the increasing amount of population, a couple 100,000 people by 2050, and with an anticipated over 100,000 new units to be built. On the right-hand side, Boston also has ambitious goals to become carbon neutral. And so we always ask the question, how do you do that? You have to build an incredible amount more, at the same time you want to reduce their carbon footprint. And at the same time, the last challenge is in North America, specifically in the US, our forests are so overgrown here, we have a lot of forest fires. And it's counterintuitive to think, but the USDA, US Department of Agriculture, is giving millions of dollars away for people to figure out how to use forest products to help alleviate the pressures on our forest here. And so for us, this emerging realm of mass timber design is a potential solution. And long story short, it's basically taking smaller lumber, dimensional lumber, and building bulk composite planks of timber, which have really great fire ratings. This is an example of an 18-story tower that was built Brock Commons in Canada. Really, you could think of these buildings as kits of parts. An example coming over from Europe. And what's really exciting is over the last year, there's been a lot of testing in seismic technologies, fire technologies, blast ratings. And so in about a month and a half, the code potentially will adapt the ability to build up to 18 stories with timber technologies in the US. So it's a really exciting time right now. So at MIT, we're basically trying to get in on the forefront of it. Between MIT and my practice here, also come up with designs. So we're looking at this space, looking at the new technologies, potentially how you can build a lot of housing, mixed-use projects, basically building these buildings as carbon sinks. So becoming carbon neutral where they store CO2. And this is looking at some of the modular affordable housing designs, different kinds of systems of these flat pack, working with Burrow-Huppold Engineering, a great firm here locally, really thinking of buildings as more sophisticated, smart assemblies. Also looking at the low-rise commercial space. This is from a team of architects and engineers we recently had together over at MIT. This is the project called BLOMDAHL, which we recently released. And we're currently going through mock-ups and prototypes of the project. So video, I won't play it. It's probably going to be too long. It's kind of cool, so maybe I'll just tease it while I finish up. So this is an example of a project where we basically, I think our core strength of looking at these technologies is in the front-end design engineering space. So this, we're looking at a building up in Toronto, and it's out of a series of these 40-foot long arches that form these box weaving technologies. And so a lot of the work we're doing is putting engineers, scientists, and designers together to really work together in integrated ways to look at how these technologies can be utilized 2018 Wood Innovation Grant. So we're building a team over at MIT and looking for development opportunities that would be interested in us coming up with design proposals for. So that just wanted to kind of throw out there in case there's any interest.
Great. Okay, well, thanks, John. So now we'll start with some questions from me, and then we'll follow with questions from the audience. And I think that I will have just a few questions because I'm sure there are a lot of questions that you all have, and we're going to try and be responsive to your own interests. But just to start, Jared, you sort of walk through your company very quickly in terms of the niche that you have in the market. Tell us a little bit about what a staging situation looks like for your company, because it is a significantly different approach to building on a site.
Yeah, so once the project has been financed, we effectively operate as a super subcontractor. So in our factory environment, we produce, similar to John, a kit of parts, except in a light gauge steel structure with as much as possible integrated into these components. So the kit might be a set of walls, floors, facade panels, kitchen pods, bathroom pods, but within each of those elements is almost all of the mechanical, electrical, plumbing, fire protection, insulation, soundproofing, even the final finish. So once our kit is delivered to site, important to note, this isn't traditional modular in the sense of a huge oversized box going down the highway. Everything has been reverse engineered to fit neatly into a standard size 40-foot shipping container that we see all the time. So when that truck delivers the components to the site, a lightweight crane is able to pick and place each component into which or onto which, if it's the floor, a concrete self-compactable concrete is cast into. Our heaviest component weighs about 8,000 pounds, which allows us to save enormously on craning costs, which in Boston, for renting a crane, some of Suffolk's projects can cost upwards of $300,000 a month, so we're trying to avoid that. Got to fire some shots to keep it interesting.
Great. Well, thanks. Megan, can you cite a few buildings in town where your panels are visible today, so that people can get a sense of your product here in our own city?
Of course. So we just completed the English Conservatory College with Sunrise Erectors. We have a metal wrap project at the Sherwin Middle School with Limo Construction, and the airport has the rental center that was also a former Wall Dimension Series project.
NIRVA, you spoke a little bit about HQ2 or actually should I say Amazon's new building here in town. Can you talk a little bit about smart building in that context?
Right. I think in that context and in many of our other project contexts, the virtual version representation is one in our offices, and we really use effectively for doing analytical business analysis on the just like for the Amazon in terms of land usage and optimization of the buildings, and really effective impact not only on the environment but the experience of the people who are actually using the building. So it's no longer just the environmental impact of the building, but just their impact to the internal user experience. So that's effectively been much of our work.
And Chris, I know that you've been very much involved in lean construction technology. Can you talk a bit about your most recent innovations in that area?
The focus that we have now, or one that comes to mind, is we're using the Vive, the headset for the 3D, and we're doing all of the MEP coordination on a big hospital here in town. So we're modeling it with the trades, put the Vive on, and then we use Iris VR as the software, and we can walk the building, and we do all the crash detection with through the 3D the Vive and to Iris VR, which is interesting.
I've had some of the videos that shows that process is really extremely beneficial now.
Yeah, fantastic. So John, be curious to hear about some of the recent research you've been doing beyond what you've already mentioned.
Yeah, so I mentioned that we recently were awarded this grant opportunity from the United States Forest Service, and so ultimately we're looking at trying to build a demonstration project here in Boston. So we have a couple potential site developments that we're starting to look at the feasibility of putting a 8-story full mass timber building up. So right now we have a team of architects and engineers at MIT, and actually a few from Harvard as well, really starting to explore that space and understand. I mean, ultimately for us, for any kind of technology to make its way into market, it has to be cost effective. And so that is a kind of driver criteria for us. And so all the work we're doing right now is building computational building information models that are also generative in the sense that they generate different kinds of designs. So you build the system, and then the system can look at the different kind of site profile and then adapt the building that has manufacturing and engineering data into it. And so really spending a lot of time looking at computational models that at the same time output pro forma information. So very effectively, the architect can increase its capacity, augment its ability from going from paper to AutoCAD, but looking at kind of more generative design processes with, kind of computer science approaches.
So I think we'll open the Q&A to the floor, and I'd love to hear some questions from the audience, because obviously that's the great way to find out what you're thinking about in the context of what you've heard from our panelists today. Yeah,
I didn't come in here thinking about this at all, but John, your model is very interesting to me. It's kind of counterintuitive about how we're now being promoted to forest, and actually extract our own forest. Can you kind of dig in a little bit deeper about the context of that and how that relates holistically with the economy and the environment?
Yeah, and so I'm not a forester by background, so I can give kind of architect's perspective, but we have around, I was actually with foresters last night, we have the New England Forestry here, it's an amazing organization. There's over 760 million acres of forest in America, and I believe 80% of those are privately owned, which contribute to the products in the built environment. And forestry practices are monitored. There's all kinds of certification processes that are calibrated on a global scale, whether it's FSC, Forest Steward certification, or there's different kinds of tiers. And so really it's about monitoring how much are you yielding to your growth cycles, and understanding you have to be able to replenish the forest with the amount you take out. And so in fact, that helps. It's a process called thinning, and so that helps with forest fires that we're seeing are a huge problem. Also with beetle infestation that is going into these overgrown forests and making these products obsolete. And so it's a big issue in America. And so potentially, if we can start building carbon sink buildings, we could bring the trees back into the city. To have sustainable approaches. So the U.S. Forest Service and the forestry here in New England is really interested, because potentially we could use local resources in New England to build these projects. And there's a factory that's getting ready to go up in Maine. So I think with the code transition, this is a pretty big time. We call it the timber age.
Follow-up question. Is Canada leading the way in this regard? We've seen some prototype buildings that have already gone up there. I would imagine the issues facing their forestry are similar, if not greater. Are you just looking at the U.S. in terms of projects, or are you looking north of the border as well?
Yeah, that's a great question. I think the leaders actually are coming from Europe. You have in London, there's an incredible amount of these buildings built, and they're brick clad, and you would never know. And you have really great manufacturing capability from some of these organizations that have been around for 800 years in the timber industry. So they have these processes mechanized. And so it's actually pretty cost effective to put panels on a cargo container from Austria and bring them over here to compete with local manufacturers right now. So the Europeans, in fact, like when we get excited about this here in the States, the Europeans are like, we do this already. And so, but the Canadians certainly, the 18-story tower was built in Canada. They have a huge forest industry. And so, you know, I think America now is starting to learn from this, and there's going to be a contribution from America where there's a lot of evolution of the technologies beyond just these big bulk plates, but new composite systems, new embedded FRP for fire rating, or different kinds of metals that have like rebar for wood capability. And so I feel like America is learning right now, but potentially starting to look at excelling with some of the technologies.
So I think we'll have one more question, and then we're going to have to break for our intermission, and then commence with our second panel after that. But yes, sir.
John mentioned about an opportunity. Are you looking for a land to build a model? Is that understand that right?
Yeah, so we basically have some funding to cover soft costs for a project, and so we're looking for progressive developers for us to come in and utilize and show that our systems can in fact be more cost effective than steel and concrete. And we work with the manufacturers and contractors from the beginning stages as an integrated design team. And so we're looking for a developer with a development opportunity that if we can demonstrate it to them, you know, we can really put Boston on the map here and show that this is how it should be done in our backyard.
Thank you.
Great. So Noah, do you have a few comments?
No. We can break for a quick 2-minute beer break, but I want to just make one plug for the Industrialized Wood Conference, which is October 24th to October 26th at the Seaport Convention Center. So that's all about industrialized wood and construction, and actually John introduced me to the Forest Economic Advisors who's putting that together. Do you want to say a quick?
Yeah.
And by the way, if you're doing any social media, it's #BuildUpSmart.
Yeah, so I think it's in about a month. It's some of the leaders from all over the world, from Europe, from Canada, that have a lot of experience, not only with mass timber, but with prefab, with light frame timber technologies, looking at modular flat pack construction. And so it's really going to be an international gathering here in Seaport. So we strongly encourage everybody, hopefully, to come out and visit the conference.
And the tickets are pretty expensive, but if you use if you use the discount code BLDUP DISC 2018, you get 25% off. So if we can do like a 3-minute break, please don't leave. The next panel is exciting. It's about technology. So let's take a quick break and we'll come back. Thank you.